Hello everybody. So looks like in this video we're going to learn what a frequency histogram is. Now let's take stock of where we've been so far. Let me get a slide from my last video where we made a frequency distribution. And this makes it easy to look at data, because in my last video, we had this raw data, which was data that represents the time in minutes that 20 different people spent reading the news. It's just a bunch of numbers with no organization to it at all. And we organized it in this table, which is called a frequency distribution. So I can look at this table and I can say, like, well, not many people spend between 8 and 15 minutes reading the news. Quite a few spend between 0 and 7 minutes reading the news, and quite a few spend between 20. So I can see how it is distributed. That's why it's called a frequency distribution. We get to see how the data is distributed. Looks like a lot of it's out here and a lot of it's here, but not so much as in the middle. So it almost makes it look like either people don't like reading the news at all, or they like reading it quite a bit. Because most of the people spend 0 to 7 minutes reading the news, or like 24 to 39 minutes reading the news. Not so many people in the middle, all right? So it makes it, the frequency distribution makes it easy to see that, all right? Okay, now a frequency histogram will take that a little bit further, and it will allow us to visualize the information in the frequency distribution, because people are generally visual. They like to see things. Sure, you can look through a table, but it might be easier to look at a picture. Okay, at least some people are like that. Now I only need one more item to show us how to make a frequency histogram, and that's something called class boundaries. So remember, in the frequency distribution, there were classes. We divided the range of data into blocks or classes, okay? The data went from 0 to 39. 0 was the smallest, 39 was the biggest, but I'm like dividing it into equal pieces, and I'm looking at it by piece. You can think of it like that. The class boundaries just take the class limits and expand them just enough to fit on a graph, okay? The lower class boundary is the lower class limit, take away 0.5. And the upper class boundary is the upper class limit plus 0.5, okay? Now, like with most things, it's easier for me to show you than tell you. So this is what they are. This is what the class boundaries are. But as the stat cat says, we'll need to see an example. It's easier to show you, all right? It makes a lot more sense that way. So let's look at an example. Let's take this. Now remember, we start with raw data most of the time, okay? And so I would like to construct a frequency distribution. Okay, so that's something we learned in the last video. And based upon that, a frequency histogram and a relative frequency histogram. And we'll use 5 classes, okay? So here's the raw data. All right, lengths in centimeters of 24 adult Fijian iguanas. So this might be something that an ecologist or a naturalist does. They go out and study a certain animal in its native population, and they want to see how their weight is distributed, or their length, or maybe they study their eating habits or whatever, but that's what this is, okay? Lengths in centimeters of 24 adult Fijian iguanas. Now remember, 24, and there's 24 numbers here, okay? This is the data. This is the raw, unorganized data. We said that 24 is the sample size. Okay, that's how many numbers there are in the data set. Okay, now let's think back to our last video. What did we do to make a frequency distribution? Well, so one thing we did was find the range. That was, in fact, the first thing we did. And that is the largest value in the data set, which if you look through these happens to be 74, minus the smallest value in the data set, which again, if you look through, is 52. So the range is 22, meaning from the smallest value in the data set to the largest value in the data set is 22. The next thing we did was we found the class width. To do that, you take the range and you divide by the number of classes. Now the number of classes is given. It says 5 classes. So we're going to break up this data set into 5 equal pieces and see how all the numbers fit. So we take 22 by 5, you'll get 4.4, but we'll round that number up, okay? And it's going to be 5. So the class width is 5. Now, do you remember what we did with the class width? Okay, well, here's what we did to make the frequency distribution. We started with the lowest value in the data set, which is 52, the smallest number here. The smallest iguana in length, in centimeters, was 52 centimeters, okay? And then we add the class width to that to get the next lower class limit. So like the class width is 5, so 52 plus 5, 57. Now remember, it's like when I do this, I do the lower class limits first. So I say 52, that's the smallest value in the data set. What if I add 5? 57. What if I add 5 again? 62. What if I add 5 again? 67. I add 5 again? 72. Now, to get the upper class limit, if the next class starts at 57, then this one ends at 56. Regarding this class, if this one starts at 62, that means this one ends at 61, and so on. Okay. All right. Now the class boundaries, I had written the definition of that on the previous page, but I said, well, you just take away 0.5 from the lower class limit and add 0.5 to the upper. So that would make the class boundaries 51.5, bumping 52 down by 0.5, and 56.5, bumping 56 up by 0.5. Okay. So there they are throughout all 5 classes. Now, do you remember how we got the frequency? Well, to get the frequency, I have to figure out, of all these 24 iguanas, how many are between 52 and 56 centimeters in length. So I have to go through and count, okay? So that would be, it turns out, 3. And then how many are between 57 and 61 centimeters in length? It turns out there's 6. Again, I have to count from all of these data. Anyway, so I continue to do that, and there we have it, okay? Do you remember what the relative frequency is? Well, you can think of the relative frequency as a percentage. Like, so 3 iguanas were between 52 and 56 centimeters, but like 3 out of how many? Well, there were 24 iguanas total, so it's like 3 out of 24. And as a decimal, that's 0.125 or 12.5%. So we could say with the relative frequency, 12.5% of the iguanas studied were between 52 and 56 centimeters. And to get this number, do you remember what we did? Well, there are 6 iguanas total between 57 and 61, but like 6 out of what? Like how many iguanas were there all together? There were 24. 6 out of 24 had a length between 57 and 61 centimeters. So that would be 25. And we do this something similar for the rest of them. 9 out of 24, 5 out of 24, 1 out of 24. Okay. Now, if I want to visualize this, here's how I do it. Okay. I would make a frequency histogram. Now, the frequency histogram is just based on these numbers. Let me show you how. It's a graph. It has a vertical axis and a horizontal axis. Okay? All right. The vertical axis is the frequency. So notice I've counted from 0 to 10. Because what was the greatest frequency? It was 9, okay? They range from 1 to 9. So I got to make a vertical axis that accommodates those numbers. The horizontal axis is the lengths of the iguanas. And we use the class boundaries for those. So the first class fits between 51.5 and 56.5, you see? Okay. That allows, well, okay, real quick, why do we do that? I didn't explain why do we do it that way. If we tried to make a graph with the class limits, there would be a gap between 56 and 57. So like, it looks nicer if these vertical bars are right up against each other. And if we just use the classes and the class limits, they wouldn't look like that. So the class boundaries nestle the classes right in there and allow for these blocks to touch each other. Now that's kind of a fine detail about it, but that's the reason, okay? So, but anyway, so I put the class boundaries in there, 5 classes, 5 sets of class boundaries, 51.5, 56.5, you know, you get the idea, all the way through 76.5. That's horizontal, okay? And then these bars here just go up to whatever the frequency is. So, you know, from 51.5 centimeters to 56.5 centimeters, it was 3, right? So I got to draw this vertical bar up to 1, 2, 3. That's how tall this one is. And then the next one, how many iguanas between 56.5 and 61.5 centimeters? Well, that would be 6. So I drew this next bar up to 6, and so on. Now, I continue to do that through the rest of them. Now this, when we draw a frequency histogram, they have certain shapes to them typically. Now, this one has what I would say is a normal shape. Okay? Now, just about everything you measure about people or animals has this shape, where most of the people or most of the animals are clustered in the middle. That's what this tells us. You know, the tallest bar, the most, you know, the greatest frequency in the whole data set was right there in the middle, okay? And what that means is most people and most things and most everything you measure about people or animals are average, okay? You know, with people's IQs or people's heights, there's kind of an average IQ or an average height, and there's not very many at the farthest lower end of that, and there's not very many at the farthest upper end of that. So like maybe among men, you know, most men are average height almost by definition. And then there very few are over 7 feet tall, and very few are under 5 feet tall. Okay, most of them are in the middle. That's just how it happens to be. So I'm not surprised with these. If you're going to measure the length of an iguana, most of them are kind of near the middle where the average is, and not so many are way bigger than that, and not so many are way smaller. Okay, so this distribution has a normal shape. Later, we'll learn when we refine this a little more that it's the true shape is probably a bell curve. Okay. If you could study all iguanas and like do like a tremendous number of measurements on there, this would probably turn into like a smooth bell curve type shape. That's something we'll learn later, but perhaps you can you have the perspective to understand that when you measure something about people or animals, most measurements are going to end up in the middle somewhere, not so many on the far ends. Okay, now that is a frequency histogram. Now I remember the question did say also, can you make a frequency histogram, which we've done, and can you make a relative frequency histogram? Well, so let's see, the StatCat will tell us about that. A relative frequency histogram is just like this, except for the relative frequencies are on the vertical axis. So for example, with the class from 51.5 to 56.5, instead of it going to 3, it would go to 0.125, okay? So your scale would be different to accommodate that, but it would just be these relative frequencies here, okay, on the vertical axis. That's the only difference. It would still have the same shape and everything, just those numbers would be a little bit different And that's all that tells them apart between a frequency histogram and a relative frequency histogram.